Hello and welcome to our session. My name is Kcse. Today we are going to work on this question. It's a question of vectors. It will be displayed on your screen. So the question says, in a triangle AOB, OA equals to vector A written there. OB equals vector B has been written there. Then you're being told M is the midpoint of AB. N is the midpoint. So it means that if M is the midpoint, it means that this one is a half, this one is half. So it is ratio is to 1:1. The ratio is 1:1. So it means that this one is 1 over the total, which is 2. And here also it is 1 over the total, which is 2. Then you're being told N is a point on OB such that ON and NB equals to 1:2. So this one is ratio 1:2. So we are going to convert that one into fraction, whereby 1, it is going to be 1 over the total, whereby the total ratio is 1 plus 2, which is 3. And then here also, now NB, the fraction is going to be 2 over the total ratio, which is 3. Then you're being told express in terms of A and B vectors, so Roman 1, so A, Roman 1, you're being told to express in terms of AB vector AB. So AB, this one is AB. If I want to go to AB, so AB, I'll go to AO, so it is going to be AO plus OB. So what is going to be my AB? My AB is going to be AO. AO, because I'm moving against the direction of the vector. Because I'm moving against, if you're moving against the direction of the vector, it is going to be a negative vector. So OA is going to be negative vector A plus OB. OB, I'm moving towards the direction of the vector. So because I'm moving towards the direction of the vector, it means that it is going to be a positive. So positive vector B. So this one can be written as, vector B. We start with the positive one, then minus vector A. And that is the answer for question Roman 1. Now let us go to Roman 2. So for Roman 2, you're being told OM. OM. Now, what do we understand about OM? OM, M is the midpoint of AB. M is the midpoint of AB. So it means that OM is going to be a half vector A plus a half vector B. Yeah, that is our OM, as simple as that. Because M is the midpoint of AB and we want OM, so it means that OM is going to be a half vector A plus a half vector B. As simple as that. There is nothing much to do there. Now, Roman 3, you're being told to get AN. That is AN. Now, AN, which direction am I going to use? I'll use this direction. That is AO plus ON. AO, I'm moving against I'm moving against the direction of vector A, which means the vector OA is going to be a negative vector A. Plus ON. I'm moving from here to here, but to the direction of the vector, which means it is going to be a positive vector 1/3 vector B. Which means what is going to be the vector? So I can rewrite this one starting with the positive value, which means I'm going to have here 1/3 vector B minus vector A. And that is my AN. So I'm done with question number A. Let us go to question number B. Question number B. Now, question number B, I'm being told if OP is equal to SOM. And then you're being told, and AP equals TAN. Then you're being told express OP in 2 different ways and find the value of S and T. Now, we are being told to express OP in 2 different ways. So the first OP, for me to get OP, it is going to be SOM. which means OP is going to be what? What is my OM? My OM, here it is. My OM is a half vector A, a half vector B. Now, in most cases, the values that we usually find here, we usually told to find here, already we've always gotten them in this specific area here. So, OP is going to be S OM. What is my OM? My OM is a half vector A plus a half vector B, which means OP is going to be a half vector A S plus a half vector B S. That is going to be my OP. Now, remember, you've been told to express OP in two ways. So, another OP, I'm going now to express another OP. So, again, OP is going to be equals to what? So, the next OP I'm going to look for OP which contain AP in it. So, if I want OP, that is OP, which means I'm going to do what? I'm going to go OA plus AP from my diagram. Now, the first OP, you'll get it from what you've gotten here. The second OP, you're going to get it from the diagram. So, OP is going to be OA plus AP. So, do I know OA? Yes, I do know OA. OA is what? OA is vector A, because I'm moving towards the direction of the vector, which means my OA is going to be vector A plus AP. Now, remember, you've been told here that AP equals to TAN. AP equals to TAN. So, it means that OP is going to be vector A plus T into vector AN. AN, we've gotten it here. Here it is. A third vector B minus vector A. So, I'm going to have there a third vector B minus vector A. So, what is going to be my OP? I'm going to open up the bracket. I'm going to have here vector A plus 1 over 3 vector B T minus vector A T. So, I have this as my OP and this one also as my OP. So, I'm having two OP. I've expressed OP in two different ways. Now, remember, we've been told to get the value of S and T. Now, what am I going to do here? The next thing I'm going to do here, because this equation equals OP and this equation also equals OP, I'm going to equate the two equations. So, I'm going to come here and say, because this one is OP, so it means that 1 over 2 vector AS plus 1 over 2 vector BS is equal to vector A plus 1 over 3 vector BT minus vector AT. Now, what am I going to do? Now, I'm going to arrange these two different equations, having A as the beginning one and then B at the end, the way this one is. So, I'm going to have this side a half vector AS plus a half vector BS being equals to what? Being equals to vector A, then minus vector AT. I'm starting with A, then plus a third vector BT. Now, what am I going to do next? Now, the next thing on your second part, this area here, remember we have A and then we have A vector AT. I'm going to equate. I'm going to factorize. I'm going to factor out A. So, I'm going to have this side 1 over 2 vector AS plus 1 over 2 vector BS being equals to vector A is the common factor between these two. Then I'm going to factor it out. I'll have there 1 minus T plus 1 over 3 vector BT. Now, because this equation is equal to this equation, it means that this A is equal to this A and this B is equal to this B. I'm going to equate them separately, which means I'm going to have here 1 over 2 vector AS equals to what? Equals to vector A into 1 minus T. So, I've equated for A separately because they are equal. What am I going to do? This vector A and this vector A is going to cancel. What am I going to be left with? I'll be left here with a half S being equals to T minus 1 minus T, 1 minus T. Then what am I going to do? Now, I'm going to make one of them the subject. I can decide to make, now let me make T the subject. If I decide to make T the subject, I can decide and bring this T this side. and take that a half s the other side. So if I bring this t this side, it will be a positive. So I'm going to have here t being equals to 1 minus a half s. So I've made t the subject there. Let me go to the second one, that is for the b. For the b, I'm going to have here 1 over 2 vector bs being equals to 1 over 3 vector bt. In this specific case also, I can see in both ends, b is common. They are going to cancel out. So that b, vector b and that vector b is going to cancel. What will I be left with? I'll be left with a half s being equals to 1 over 3 t. Remember here we made t the subject. We need to make t the subject here also. What am I going to do? Because this one is a third, I'll multiply both sides by the reciprocal, which means I'll multiply here by 3 over 1, multiply there by also 3 over 1. That, and that will cancel. So I'll remain there with the t being equals to what? T being equals to 3 over 2. So I've made t the subject here, have made t the subject here, which means I can equate these two equations to get the value of. So here actually it is going to be t equals to 3 over 2 s. Don't forget about the s because we are equating. So 3 over 2 s. So I'm having this equation as t and this equation as t. Now because these two equations are similar, I'm going to equate them. Let me rub here. So these two equations, because both of them are t, I'm going to equate the two of them. I'm going to say here 1 minus a half s equals to 3 over 2 s. I can get the value of s there. I'm going to collect the like terms, or first of all, I can decide and cancel out the denominators by getting the LCM. So I'll put this one over 1, get the LCM. LCM of 1, 2, and 2 is that is 2. I'll multiply here by 2, multiply there by 2. Multiply there by 2, multiply there by 2, which means what I'm going to be left with here, it is going to be 2 being equals to that 2 and that 2 will cancel. I'll remain there with s. Then no, 2 minus s, sorry. So I'm going to have 2 minus s being equals to what? There, this 2 and this 2 will cancel. I'll remain there with 3s. I can get the value of s there. I'll take that s the other side, it will be a positive. So I'll have here 2 being equals to 3s plus s, whereby I'm going to have here 2 equals to 4s. If I want to get the value of s, I divide by the coefficient of s, which is 4. So divide there by 4, divide there by 4, which means s, in my case here, it is going to be a half. So I've gotten the value of s. Having gotten the value of s, which means I can get the value of t, I'll take the value of s and equate it in any of these two equations. Let me equate it to the second equation. So the second equation tells me that t equals to 3 over 2 s, and I know the value of s is a half. So I'll come here, say t equals to 3 over 2 into s. My s is a half, which means what am I going to have as the value of t? So the value of t is going to be 3 over 4. So I'm having s as a half and t as 3 over 4. And those are the values of what? Those are the values of s and t.